Okay, so for this deep dive, I want you to just close your eyes for a second. Picture this.
Okay.
The year is 2007. You're standing in a village in Bihar, India. It's one of the most densely populated places on the entire planet.
Millions of people, right.
Millions. But the sun has just gone down.
Yeah.
And all of a sudden, it's just nothing.
Total darkness.
Yeah.
And, not the kind of darkness we might experience when a storm knocks out a power line for an hour.
No.
We're talking about a pervasive nightly reality.
Right. I was reading the background for this, and the stats are just staggering. In 2007, something like, 85% of the population in that region had effectively zero access to electricity.
Nah.
When night fell, the world just stopped.
Or it switched to a very, very dangerous alternative.
Yeah.
Kerosene.
Ugh, kerosene.
If you want to see your hand in front of your face, you are lighting a kerosene lamp.
Yeah.
Which is, it's essentially a glass bottle filled with low-grade fuel and a rag.
It's medieval. It smells awful. It produces this thick black smoke that just coats your lungs. The light is dim and flickering.
And a massive fire hazard.
A huge fire hazard, especially with homes that have thatched roofs.
It's a trap, really. It's expensive. It consumes a huge chunk of a person's daily wage, and it keeps people stuck in poverty because you can't work or study effectively. It was a literal dark age in the 21st century.
But that sets the stage perfectly for today's story. We are diving into Husk Power Systems. And on the surface, this looks like a story about electricity. But, digging through these sources, it feels much more like a masterclass in business resilience.
Absolutely. It's a story about innovation, sure, but it's also about bottom-of-the-pyramid economics.
Right.
Surviving that valley of death that kills almost every hardware startup.
Right.
And pivoting from a scrappy experiment in India to becoming a major utility player in Africa.
So let's meet the characters. We have this group of friends, Kanish Pandey, Ratnesh Yadav, Manoj Sinha, Chip Ransler. They're from Bihar, but they've left. They've got successful careers, or they're studying in the U.S. and Europe. They really didn't need to come back.
No, they didn't. They had the exit, so to speak. But they had this nagging pull to solve the energy crisis back home. And interestingly, they didn't start with the solution we're talking about today. They tried the usual suspects first: solar, wind, biodiesel.
But this is 2007. I'm guessing the math just didn't work.
Not even close.
Yeah.
You have to remember, in 2007, solar panels were astronomically expensive.
Right.
We're talking nearly 20 times the cost they are today.
Right.
If you tried to build a solar plant for villagers earning $1 or $2 a day, you'd go bankrupt in a week. It just wasn't viable.
So they're stuck. They want to bring light, but the tech is way too expensive. So they look around at what the villages do have.
And Bihar has a lot of rice.
Okay.
Mountains of it. And specifically, rice husks. When you mill rice to get that white grain we all eat, you're left with this hard, silica-rich shell.
Which is basically just trash, right?
It's worse than trash.
Yeah.
Animals won't eat it because it's too tough.
Yeah.
It doesn't burn well in a normal cooking fire because it just smokes. So it was just piling up in these massive mounds, rotting or being burned in the fields just to get rid of it.
So here's the aha moment. They have a fuel source that is not just free, it actually has negative value. People want it gone. But how do you turn a pile of rice shells into electricity? The term in the notes is biomass gasification. Can we break that down? It sounds a little like high school chemistry class.
It is, but it's fascinating. So simply burning something is combustion. You add oxygen, it burns, you get heat and smoke.
Right.
Gasification is, it's different. You heat the biomass, the rice husks, in a very low oxygen environment. You basically starve the fire.
So you're kind of cooking the husks without letting them fully burn?
Precisely. And when you do that, the material doesn't turn to ash immediately. Instead, it releases this flammable gas, a mix of hydrogen, carbon monoxide, methane. You capture that gas, clean it, and then you feed it into an engine, just like you'd feed gasoline into a car engine.
And that engine spins a turbine and voila, electricity.
You got it.
But the notes highlight a specific innovation here: dry gasification. Why was that distinction so important? Why couldn't they just, buy a gasifier off the shelf?
This is a really crucial technical detail. Gasifiers existed, of course, but they were designed for different contexts. The gas they produce is dirty. It's full of tar and particulates. The standard way to clean it back then was to wash it with water.
Which creates sludge.
Toxic, black, tar-filled wastewater.
Yeah.
Now, if you're a big industrial plant, maybe you have a way to treat that,
Right.
but you cannot dump thousands of liters of toxic sludge in a rural village.
No way.
You'd be solving the energy problem, but creating an environmental disaster.
So the Husk team had to play inventor.
They did. They spent months experimenting, and they engineered their own proprietary dry filtration process. It cleaned the gas without using water. This was clean tech before clean tech was really a buzzword.
And this let them build these mini pecker plants. What were they, 35 kilowatts?
Right. Just picture a small shed, a hopper full of rice husks, an engine chugging away. One of these units could power about 300 to 500 households within a pretty small radius, maybe 1 to 2 kilometers.
And I love the logistics here because it shows they were thinking about the whole supply chain, not just the tech. They didn't just put these plants in the middle of nowhere. They used a cluster strategy.
It's basic physics applied to business. Rice husks are light and bulky. If you have to put them on a truck and drive them 50 miles, the transport cost eats your entire profit margin.
Of course.
So they built the power plants directly adjacent to the rice mills.
So smart. The fuel travels 0 miles.
Exactly. They ensured a steady fuel supply within a, say, 5-kilometer radius. They turned a waste disposal headache for the millers into a consistent fuel source for the village.
So let's walk through the launch. They flip the switch. What happens to the village?
The change is just visceral. Initially, they only ran the plants for about 6 to 7 hours in the evening, say 5 p.m. to 11 p.m. But you have to think about village life.
That's a golden window.
That's everything. That's when you cook, that's when you socialize, and critically, that is when kids do their homework.
The sources mentioned that students could finally read textbooks at night without breathing in kerosene smoke. That alone is a massive developmental leap.
It is. But here is where I want to pause and look at the business model. Because as heartwarming as the impact is, if the economics don't work, the lights go out in a month.
Right.
How do you get people who earn maybe $2 a day to pay for a utility service?
This is the classic bottom of the pyramid challenge.
Exactly. Husk knew they couldn't send a monthly bill in the mail. These customers don't have bank accounts, they don't have postal addresses or monthly salaries. They live day to day.
So they went with a prepaid model.
Pay as you go. Like a burner phone. And the pricing had to be psychological as much as it was financial. They charged roughly 80 to 120 rupees a month. That was about $1.80 to $2.50 back then.
Which sounds incredibly cheap to us, but that's a real expense for a villager.
It is, but here's the key.
Yeah.
It was cheaper than what they were already spending on kerosene.
Ah, that's the hook.
That's the hook. Husk didn't have to convince them to spend new money. They just said, look, give us the cash you're already burning on dangerous, dim lamps, and we will give you bright, clean electric light. It was an immediate value upgrade.
But there's a catch with selling electricity in developing markets, right? Theft. I've read that power theft is a huge problem in India. People just hook a wire onto the line. How did Husk stop that?
They needed a smart meter. But this is 2008, 2009. A smart meter in the U.S. cost hundreds of dollars.
You can't put a $300 meter on a house that pays $2 a month. The ROI would take a decade.
It would never work, so they built their own.
They built their own smart meter.
They stripped it down to the absolute basics. They built a $5 smart meter.
$5.
$5. It didn't have a fancy touchscreen or Wi-Fi. It just did the one job it needed to do. It tracked usage, and if the prepaid credit hit 0, it cut the power.
It automated the bouncer role.
That's a great way to put it. They didn't have to send someone door to door to collect cash or cut wires.
That is frugal engineering at its finest. Now, speaking of squeezing value out of everything, we have to talk about the incense sticks. This part of the research, it's brilliant.
It's the ultimate waste not, want not.
Yeah.
So when you gasify rice husks, you are left with this black, silica-rich ash called char. It's the waste product of the waste product.
Okay, so most companies would just dump it.
Right. But Husk realized that this char was actually a perfect binding agent for making agarbatti incense sticks.
And India consumes a massive amount of incense.
A huge amount. So they set up these micro-enterprises. They employed local women to roll these incense sticks using the char. So let's trace the value chain again. Farmers grow rice. Millers create waste husks. Husk Power turns husks into electricity and sells it. The waste from that process becomes incense, creating jobs for women and a second revenue stream for the company.
That is a fully closed loop. It sounds, well, it sounds perfect, but, you know, stories like this rarely stay perfect.
They don't. And around 2013 to 2015, the company hit what the sources call the Valley of Death.
Right. This is where the startup almost died. What went wrong? Was it the technology?
The technology was tricky. Gasifiers are temperamental. They clog. They need maintenance. It was an operational headache. But the real existential threat came from outside. The Indian government finally decided to get serious about grid extension.
The big grid showed up.
They started aggressively running wires to these remote villages. Now, the government grid in rural India is notoriously unreliable. Blackouts are common, but
Or,
it's heavily subsidized. It's cheap.
and if you're an investor looking at Husk Power and you see the government marching in with these big transmission towers,
You panic. You say, why would I invest in your little mini-grid when the state utility is arriving? The funding just dried up. Husk was squeezed between its own operational headaches and a looming competitor with basically infinite pockets.
this feels like the moment where most social enterprises just fold. They did some good, but the
Yeah.
market shifted. How did Husk survive?
They pivoted hard. It was a massive strategic shift. They realized that biomass alone wasn't the future. They needed to embrace the enemy of 2007.
Solar, because prices had dropped that much.
Yeah, it absolutely plummeted. By 2014, solar was affordable. But more importantly, the customer had changed. This is a fascinating bit of psychology.
How so?
Once people got a taste of power in the evenings, they stopped being satisfied with just lights. They became aspirational.
They wanted fans, TVs.
Exactly. They wanted power during the heat of the day. They wanted 247 reliability. Now, running a biomass gasifier 247 is a nightmare. You need constant fuel loading and maintenance. But solar loves the day.
So they mashed them together, the solar biomass hybrid.
That's it. Solar panels handle the daytime load. The biomass gasifier kicks in at night or when it's cloudy, and batteries smooth out all the gaps in between.
That sounds incredibly complex to manage.
It is. It required much better software to balance all those loads. It allowed Husk to completely change their sales pitch. They stopped competing on "we have light" and started competing on "we have reliability."
Because the government grid was so unreliable.
It was awful. It might be there, but it was off half the time. Husk could go to a shopkeeper and say, sure, the grid is cheaper when it works, but we work 200/7. Your freezer won't melt with us.
Reliability became the product. That's a huge shift. And this new model, the hybrid grid, was scalable, which I guess brings us to the next chapter, Africa.
Right. They proved the model in India, but the vision was always global. They expanded into Tanzania and Uganda.
Now, I've traveled a bit, and I know you can't just copy-paste a business model from Bihar to Tanzania. The context must be totally different.
Completely different. So one, the geography. Bihar is incredibly dense. You can run a wire 500 meters and hit 50 houses. In rural Tanzania, people are much more spread out.
So your infrastructure costs skyrocket. You need way more wire per customer.
Correct. And then there's the fuel. Rice isn't the dominant crop in every part of East Africa. You don't have those massive piles of husks everywhere.
So what do they burn?
They had to adapt the gasifiers to use corn cobs.
Corn cobs. Really?
Yep. Maize is huge in East Africa. But burning a corn cob is different from burning a rice husk. The density is different. The burn rate is different. They had to re-engineer the system to be fuel agnostic.
That's impressive adaptability. But they did have one huge advantage in Africa that they didn't have in India. Yeah.
Huge. Mobile money. M-Pesa.
Explain that for listeners who might not know the scale of it.
In East Africa, mobile money is king. Almost everyone pays for everything via text message on their phone. In India, Husk had to employ people to go collect cash, which is slow and prone to theft.
But in Tanzania...
In Tanzania, billing is instant, automated, and totally frictionless.
Wow. So the financial infrastructure, the fintech, actually unlocked the energy infrastructure.
It accelerated it massively. And the African customers were different too. They were tech leapfrogging. The sources say many customers there wanted to power TVs and fridges on day one. They completely skipped the just a light bulb phase.
Which pushed Husk to deploy those more robust hybrid systems from the get-go. Now, we've talked about lights and fans, but I want to get to the deeper impact. The notes mention something called the ice cream effect.
Ah, yes.
This feels like the emotional core of the story.
It really is. We often think of rural electrification as, oh, now they can see at night. But the real power is economic. There's this story about a village entrepreneur in one of Husk's territories. Before the power arrived, he was just a small shopkeeper.
Living by the sunset, essentially.
Right. But once Husk provided reliable, 247 AC power strong enough to run motors and compressors, he took a risk. He bought a freezer.
Which would be a paperweight without reliable power.
Exactly. With the grid, he'd lose his whole inventory. With Husk, he could keep things frozen. So he started making ice cream.
In a village that had probably never even tasted ice cream before.
And the demand was just wild. He bought another freezer, then another. He ended up with 10 freezers, selling 2,000 ice creams a day. He hired staff. He became a local tycoon.
That's the multiplier effect.
It is. It's not just consumption, it's production. It's the welding shop that opens, because now they can run an arc welder. It's the grain mill that switches from a dirty diesel engine to a clean electric motor. It's the water purification plant.
It changes the fundamental economics of the entire village.
And the environmental impact. Every time a grain mill switches to husk power, they turn off a diesel generator.
Right.
We are talking about offsetting millions of liters of fossil fuel.
So bringing it to the present day, Husk Power didn't die in that valley of death. They're in India, they're in Africa. What's the scale now? What's the end game?
The ambition is huge. They have a stated goal to build 5,000 mini-grids. But what's really interesting is that they are evolving into a tech company. They aren't just building poles and wires, they are building an AI-enabled platform to manage all these distributed assets.
A virtual power plant.
Basically. They can monitor thousands of batteries, solar panels, and gasifiers across 2 continents in real time. They're optimizing loads, predicting demand. They're even talking about an IPO.
An IPO? For a company that started by burning rice husks in rural Bihar, that is a wild trajectory.
It signals something really important. It signals that rural electrification isn't just a charity project or an NGO mission anymore.
Yeah.
It's an investable asset class. It's a real business.
And that leads me to my final thought. I want to zoom out here. Why should a listener in New York or London or Tokyo care about a mini-grid in Tanzania?
Because it challenges our entire definition of what infrastructure is supposed to look like. For the last 100 years, the developed world has relied on the big grid. Massive centralized power plants, coal, nuclear gas pushing power over thousands of miles of dumb wires.
It's the mainframe era of energy.
Exactly. But what Husk Power is building, that's the internet era of energy. It's decentralized, it's modular, it's intelligent, and it's hyperlocal.
If a storm hits the main grid in Texas or California, millions of people go dark. We've all seen it happen.
But if you have a network of thousands of autonomous solar hybrid mini-grids, the system is resilient. If one goes down, the rest stay up.
So in a strange twist of irony, the so-called developing world might actually be building the prototype for the developed world's future energy grid.
That is the provocative thought I would leave you with. We think we're helping them catch up to us, but in reality, they might just be leapfrogging us. They are building the resilient, distributed, renewable grid that we are all going to need in the next 20 years.
From rice husks to the blueprint for the global energy future, that is one hell of a deep dive.
It really shows you that innovation often comes from where the constraints are the highest.
Well said. That's all for this episode of The Deep Dive. Thanks for listening, and we'll catch you on the next one.
Thank you for listening to Mission Possible, innovating for the world's most marginalized. This podcast is built on the outstanding work of our students, whose curiosity and commitment drive much of the research and storytelling you hear. Each episode is grounded in academic research and shaped through close collaboration with our partners. To learn more about the research and partnerships behind this podcast, feel free to contact us. Thank you for joining.